Hi there. Today we're moving into the next section. We're talking about stars. This is a section that we'll be spending. It's one of the bigger sections, stars. So we in this class are going to be talking about what makes a star, how a star works, and the life cycle of a star. Now, a star isn't a living thing, but it has a cycle that it goes through depending on the size of the star, depending on the mass of the star. Uh, it'll grow and change into different stages of its life, quote unquote life. What we're going to be talking about in this video specifically are two main points. What is a star and what is fusion? Um, the first part is very easy. A star, I've got a definition right here for you. It's a large, self fueling celestial body capable of nuclear fusion. Now, you might not know what that term nuclear fusion means, but that's what this video is for. A star, as you know, is a big ball of burning gas up in the sky. We have one that's pretty close to us, we call the sun. It goes through all of these processes that we're about to talk about today, but it's not alone. Every star you see up in the night sky goes through fusion, nuclear fusion. That's what keeps it burning, that's the fuel. Now, in order to talk about nuclear fusion, we have to look at the periodic table of elements. And you might be familiar with this periodic table, or you might not be. If you've taken physical science or you've taken chemistry, you've probably seen this before. And if you haven't taken either of those things, you've probably seen it before anyway. This is a table that shows all of the elements uh, in the universe that we know of. Uh, it's we're not going to get super in depth talking about what makes all of these different elements special. All that you need to know for this class is that these numbers next to each of the elements indicates, for simplicity's sake, the size of these elements. Okay. It tells us how many protons each of these elements has. So our first element on the periodic table, element number one, that's hydrogen. It has one proton. We can call it size 1. And as we go up the scale to helium, it has 2 protons. It is size 2, basically. And 3, lithium, it's getting a little bit bigger. Beryllium, a little bit bigger. Boron, a little bit bigger. So on and so on and so on. Okay? Now, in a star, uh, some of these elements exist already. Typically, it starts out with the simplest element, which is hydrogen, number 1 up here. It's the smallest, it is the simplest, it is the lightest weight wise. It has a mass of basically 1. So, as time goes on, over a long enough period of time, hydrogen atoms that are up there floating out in space, little specks of hydrogen, eventually get attracted to each other through everybody's favorite force, gravity. Gravity attracts things that have mass. And so eventually, oh, hey, hydrogen atom, oh, hey, hydrogen atom, we're going to slowly get pulled together until, oh, we have 2 hydrogen atoms that are little buddies. Oh, now we have a little bit more gravitational pull. Let's pull a couple more hydrogen atoms, a couple more hydrogens, a couple more hydrogens, a couple more hydrogens over thousands and thousands and thousands of years. So it takes a really long time for all of these hydrogen atoms to get closer and closer and closer until eventually there's enough hydrogen atoms that the gravity of this mass, all of these hydrogen atoms, is pulling itself in with a great deal of force. Because now this collection of hydrogen atoms has gotten heavy. So gravity is pulling it in with a lot of energy. And eventually, all of that pressure from gravity squeezing all of these hydrogen atoms together eventually will squeeze some of these hydrogen atoms so much that they fuse together. Hydrogen atom number 1 and number 1 fuse together to create, you guessed it, number 2. The mathematic geniuses amongst you can figure that one out. So what the star does is, move me down here, is take some of these hydrogen atoms, hydrogen plus hydrogen. Ugh, that doesn't look right. Erase this. Boo, hiss, terrible. Uh, boop, bang, pow. Make this thinner. Basically, what we do is we take hydrogen plus another hydrogen. Remember, these are both ones on the periodic table. We fuse them together, nuclear fusion, and we get a helium atom out of it. Number two, right? So we take two of these hydrogens and we fuse them together to create a helium atom. Now, this helium atom is a little bit bigger, it's a little bit heavier, and when this happens, we release some energy. And I'm gonna shorthand it NRG. Okay. So we fuse hydrogen atoms together, we get a helium atom, and it creates some energy. That is what keeps the star moving. This is our fuel. There we go. That's the fuel that keeps the star moving. That's all of that energy. So stars are constantly doing this. Once they reach this point and they fuse their first two hydrogen atoms together, we have a star. We've fused hydrogen and hydrogen to get helium. We've gotten some energy out of it. Now it's star time. So we keep on doing this process. Hydrogen, hydrogen, helium. Hydrogen, hydrogen, helium. Hydrogen, hydrogen, helium. And we get some energy by doing that. Now, the star, so that's fusion. Basically, we're taking two smaller atoms and we fuse them together to get something a little bit more complicated and create some energy from it. So our star, the sun, is doing this right now. Basically, there are layers of the sun. How do I want to go about drawing this? Black, yeah. All right, so basically there are layers of the sun, just like how there are layers of the earth, and as we go deeper and deeper, different things are in there. And so the sun right now is fusing together hydrogen and pumping out helium. Now, obviously, since that helium is heavier, remember it's element 2, so it has a mass of, for our purposes, 2, twice as much as hydrogen. That heavy stuff is more dense, and so it gets brought closer and closer to the center. So out here we have all of our hydrogen closer out to the outside, and that helium is getting moved inside. Okay. So when heavy stuff gets created, it gets shoved down into the middle, deeper into the star. And so we get more and more pressure because the star now is getting heavier and heavier. As the star gets heavier, now all of a sudden the gravitational force is stronger because heavier objects have stronger gravity. So we have gravity pushing in on this star. This is gravity. And like I say here, this is a balancing act. So right now we have gravity that's pushing in on the star. It's like a water balloon. It's trying to pop this star. Gravity is pushing in on it. But inside the star is this nuclear fusion happening. So we get this nuclear fusion that is creating new atoms and creating new energy. So inside the star, we have fusion. Oh boy, fusion. That's creating energy and pushing out from inside of our star, inside of the water balloon. So it's this balancing act of gravity pushing in and fusion pushing out that maintains this circle shape. If gravity were too strong, it would pop the balloon. And if fusion were too strong, it wouldn't maintain that star shape and all the atoms would just go flying out into space, which is something that happens once we get to it later. So these two forces have to be in balance. As fusion is pushing out, it has to be roughly the same strength as the gravity that's squeezing in. So that's what all the stars in the galaxy are doing, all the stars in the universe are doing, balancing between how strong gravity has to be and how much fusion we can do. The more complicated the atoms, the heavier the atoms, the more energy we get, but also the star gets heavier, so gravity is stronger. And so we sort of go up these stages. More complicated atoms gives us stronger fusion, but it also gives us stronger gravity. And so the star is getting heavier and stronger and heavier and stronger and heavier and stronger as it goes along. Our sun right now is about halfway through the process of converting hydrogen into helium. Uh, I don't know the exact time frame, but it's millions of years in the future. Now, eventually, we I'll keep some of these. Never mind. It's too late now. Eventually, we get to the point where we have this next layer, right? A helium layer inside here, and our hydrogen layer inside here. Eventually, though, we're going to start running out of hydrogen because we're converting it all into helium. So we get to the point where eventually we're running out of hydrogen. It's become too much helium. So now the star is a lot bigger. Gravity has a lot more pressure on it. So we start converting the helium into something else. So let's go back to our periodic table. Now all of a sudden, instead of fusing hydrogen and hydrogen to get helium, we might be converting, let's say, hydrogen and helium to get lithium. A 1 plus a 2 gives us a 3. Or maybe we're converting helium and helium to get a 4, beryllium. Okay? Both of these things are heavier, so we're going to start to get more and more layers inside of our star. So maybe we have a hydrogen layer and a helium layer and a beryllium layer. The heavier the element is, the deeper inside the star it's going to be. But there's still fusion happening all the time. We might be fusing hydrogen into helium and helium into beryllium and hydrogen and helium into something deeper inside. So we get layers and layers and layers. And depending on the size, the mass of the star, we're only going to get so many layers. But some stars are very, very big, like this one. Oof, even bigger. It's the really, really big stars. They go through this process of fusing small stuff into bigger stuff, into bigger stuff, into bigger stuff, into bigger stuff, until we have loads of layers inside this star. Let's see if I can just make a bunch of shapes here. Ooh. Lots and lots of different layers. Oh, man, it's going to be the same color. Whatever. You get the gist. Lots and lots of layers of heavier and heavier elements inside of this star. Okay? And each of these layers are feeding into the next layer and feeding into the next layer and skipping some layers and feeding in and feeding in and feeding in. And so the star is getting heavier and heavier and heavier. And the force of fusion is getting stronger and stronger and stronger. And the force of gravity is getting stronger and stronger and stronger. And you can maybe tell where this is eventually heading. That there's just so much strength and so much fuel and so much energy and so much gravitational force that eventually the star can't keep up anymore and it dies, which is what we're going to talk about next time. All right? So, look forward to that one. Of course, if you have questions, please let me know. I'll talk to you next time. See ya.